Okay, I guess. Hi everyone. Welcome to the second Zürich Meetup. This is the Simplificator office. Yeah, glad you're here. By the way, we're hiring, so if you know anyone or are interested yourself, we do Ruby on Rails as well as iOS and Android development. So if you know anyone, particularly for the Rails part, we're looking for people. So yeah, whatever. So yeah, without further ado.
Hi, my name is Dimiter. So it's Paul. I'm going to talk to you about a silly game I made. Like it's a clone of that game where you break bricks. I have played all of. Does it work? I should have tested this. No, I have a version working somewhere. Games. I don't have my games. I should. Yeah, so it's really silly, really simple. So my goal with this was to. So I don't really make games for a living, not even for fun. I wanted to try copying a simple game so that I could both like learn something about simple game mechanics like collision handling and so on, and also use Elm in a project that I can define as finished. Well, this is like really simple because I got actually annoyed by this game. It's I should have found a better idea, something more engaging, but it's still like a complete project. Like you can, as you saw, you can lose and it starts over, and you can like clear the screen. So it sort of works, and I want to show you the code. What is your experience with Elm? Like, is there anybody who hasn't seen any Elm code here? Okay. Right. Okay. So Elm is a language that is compiled, and right now the only target is JavaScript. Like it compiles to JavaScript, but it's not like CoffeeScript where it's explicitly you compile to JavaScript. Elm will have different backends in the future. I think WebAssembly, maybe Node, maybe something else that's like not the JavaScript virtual machine. But right now it's the way it works. So it has some documentation. Well, recently a new version came out, so some of the stuff you may find online is not up to date. But like the packages are, and the core documentation is. So yeah, let's dive right in. So. I guess a simpler way would be to start with a hello world, because it's better than to dive into the game code immediately. So in Elm, we have types. So it's like the types are checked at compile time, but you don't need to write them out. The Elm compiler can infer the types of your functions. So here, the type is something like HTML.
Yes.
I think. I don't know if there's a way to evaluate this. No, it's not HTML. It's HTML. Exposing HTML. No, but it's something else.
I think now you don't have to write HTML, just HTML. Right?
Yeah, but
you're missing a message behind or something.
Yeah, I think so.
Nothing.
Anyway, it's like the worst presentation. No, Hello World is not very interesting, but that's
too difficult.
So the Elm has something called the Elm architecture, and it's the way that you structure every program, basically. What you do is, let me see if I can find the documentation. The way you do things is that you have a main program. So this block here, and you say that you have something to visualize the current state of the program, something to initialize the state of the program, some step function that will take the current state and some information and return the new state. And then we'll talk about subscriptions later. It's basic interactions with the outside world. So Elm is a pure language. So we'll see how it handles side effects, but in the code, wherever how can you explain this? You cannot cause a side effect from your Elm code directly. What you do is, if you want, for instance, to do an HTTP request, you will say, oh, by the way, this function asks for a HTTP request, and this is represented as data in your program, and then the Elm runtime will do the request and then return you the result through, we'll see a subscription, but just, yeah, if we don't worry about the outside world, like it's a purely functional language. Right. So, I'll start with the view function. No, yeah. Let's start with the model. So here we have something called, so this is a record. So if you're familiar with JavaScript, it's like a JavaScript object, but with types. So in my game, I have this thing here, the paddle, I have the ball, and I have a list of different bricks. So the way I model that is to have the x coordinate of the paddle, because it only moves in one direction.
Is that the middle of the pad? The center of it?
No, I think it's the top left. But it might. I think in the code, whenever I move the mouse, I calculate so that the middle of the pad corresponds to the middle of to the mouse position. Mm-hmm. Then, well, ball position and ball velocity. Right, something to indicate whether I've started playing the game. So here, launched is false, and then list of bricks. So this is the model. I have a function called init that basically represents the initial state of the program when you started. So yeah. Don't worry about the message so far. So just this thing, this is a tuple, so it's you're familiar with the concept? No? Yes. Mm-hmm. Just two things. And here I do some calculations which are boring, but basically this is the important block here. Okay, so this is the important block here. I just returned the initial stuff. So the game is not launched. There's a list of bricks that I compute the positions of here, and then the initial ball position and so on. And then we have a view function. that basically returns some HTML. So this is this here. It's not markup. It's a function call. So I'm calling the function called div that takes two arguments, which are both lists. So this is the first list containing well, style information, but I think various attributes. And the second list contains the children of this element. So div, yeah, it's defined in the HTML package. And yeah, so this is nice because what it means is that your view is code. You can if you need to filter some data, to compose your functions however you like, you can do it. And for this I'm using SVG, and basically it works the same way. I just figured out some function calls. Right. So yeah, the update part, this is how you change the state of the game. So Elm has so in the Elm architecture, you define the types of actions that you can do in your program. So this thing here, message, it's just a conventional name of the type that defines the possible actions. It used to be called action, now it's message, and like I don't necessarily like the abbreviated style, but it's a convention, so we just follow conventions. So we can do 3 things in the game: move the pad. We can start the game, and then we can get the time lapse. It's just it's a tick that says, so it's I'm using the request animation frame API, and this just updates every time the browser gives you the opportunity to render something, so that it's smooth at 60 FPS. So this is called a union type, I think, or a tagged union. So this is so we have many messages, and they all have some kind of tag. It's like a name for the message, and this is the parameter of the message. So, for instance, tab move. So and we use this in the function. The update function receives a message and the model, and returns the new model and eventual side effects. But since now you have to be exhaustive about how you treat pattern matching. So I don't know if you're aware, familiar with pattern matching from other languages. Yes, everyone? No. So in Ruby you would have a case statement. Or in JavaScript, you would have a switch statement, And so in Elm, you have a similar construct. You say case, it's like saying switch on this thing, and then you can match on the different types of values it has. And the advantage of Elm is that it's exhaustive, it checks that you have treated every possible case. So if you don't have a default case, or if you haven't tried all the branches, the compiler will actually give an error. So yeah, so as I was saying, the pad move. So this is the tag, like the name of the message, and then it has a parameter which is the position.
I have a question. So what do you do if this pattern matching has to be complete? Yeah. Do you define all the messages up front with dummy actions, or do you do one at a time?
So it's actually you define the messages as you go along. So if now like this compiles, I don't know if you can see it, like I have a shortcut in there. It's really like the Vim plugin is really good. It's fast and it shows you the errors and everything. So now if I add a new type of message, like a no-op message, now it says, let's open it. Yeah, so now it says, oh, you need to account for the following values, blah, blah, blah. Add a branch to cover this pattern. So what you do is actually at first you might not have thought about all the possible things in your program, and you just start, and if you forget something, the compiler will remind you. So one way I can use this is just have, here I can have a catch-all. This will work, yeah. Or I can handle the message. But yeah, that's how we do it. Which is really good because when you're refactoring, you want to be reminded about stuff like that. Okay. So next, oh yeah, and subscriptions. So subscriptions are ways to interact with the outside world. So here I defined three subscriptions. So one is about mouse movement. I can actually show you the documentation. Yeah, so this one tracks the mouse movement, and then you have like clicks and other stuff. And the track also moves mouse up, so that when I release the button, it actually starts. And then I have this, the animation frame. So it just calls the request animation frame API, and it's diffs because I don't remember the difference, but I think one gives you the current time, and the difference gives you the time from the last time you called it. So that way I can get a delta in my game and just update the game state by this delta in time. Does this make sense so far? Right. So yeah, you're saying you have these things from the outside world, and you kind of map them to messages in your application. And so this is how you get messages from the outside. There's a way to do it the other way, but I don't need to cause any side effects. Well, actually, I draw the stuff, but Elm takes care of all of that for me, like rendering the game, rendering the HTML and the CSV, SVG. Right. Yeah. I don't know. I can show some game logic or some stuff about like collisions and so on, but I might as well show you how I wrote some tests. So Elm has testing framework. Right. So you declare a suite of tests, and then you run it here. And I decided to break it up into subsuits because then I can add stuff like collision tests and so on. So the vector tests. I have two types of tests. One is just the kind of tests that you would have in other languages, like unit tests. And I have basically checked basic stuff. And the interesting aspect is that I also added property tests. So property testing is about defining something, some fact about your code that holds true in all cases. So as long as you define a range of inputs. So in this case, what I do is I create example vectors. So they're 2D vectors. So the Elm check, so this is the property-based testing library. It has something that will produce random tuples, and then it can also produce floats. So I'm saying that I want you to give me like a tuple of floats, and then I'll map it into a vector myself, and then you can use this in the tests. And what it will do is it will actually run your tests with an array of different values, possible values for a vector. So in this case, it will be like this, and also and so on. It will do, I think, 100 values, and if there's a failure, it will try to reduce the range and find the edge case where your code breaks.
You have to way to control, I don't know, the number of digits behind the comma or the range of the values produced, or
yeah, so in my case, it's actually, I defined as a thing called assert equal in delta, because when you have, how do I use it? Yeah, so I'm saying, like one example, addition is associative, so if you do X, no, sorry, let's try.
I mean, for the generated values,
Yeah.
do you have some kind of way to...
No, I don't know exactly what it generates. Check. Yeah, it just says they're generated for like a producer for float values.
the range float maybe?
Yeah.
But this does the right thing because my test actually failed. Because with vectors, so like when you have vectors of integers, it's fine. But in some part of the code for collision detection, I used to use floats because there's a square root somewhere. So you need to represent your vectors as vectors of floats. And so when I did this thing where you're basically saying, oh, I can add, like you can do x plus brackets like y plus z, and it's equal to the other way around. If I don't, let's try it this way. We're claiming that this is, by the way, the backticks. It's just instead of writing vec to add xy, I can write x like vec to add y. So it's in to do it infix. And when you import the vec2 namespace, you can have it like this. But it's also a convention to be explicit, but just and to write the normal form, not the infix form. But like this framework, I think it actually reads better when you have it infix, and that's how it's in the documentation. So yeah, let's try to run this. So if if I say I have three vectors x, y, z, and then we do this.
What's backslash?
So here I'm defining an anonymous function. So it's like in yeah,
So
like
put the
a
backslash.
It's like an anonymous function in JavaScript or something, but
Yeah.
X, Y, and Z are actually
the arguments.
the arguments for the function.
So here, instead of like I could have had like add equals this, so x, y, z. But instead of doing this, I write it this way because it's like here it's shorter. I'm not going to define an external function just for my test case because I have a lot of those. So it just makes sense.
So the backslash is to differentiate it from tuple.
The backslash is supposed to look like a lambda.
Oh, okay.
So it's basically saying I want a lambda with these
Okay.
XYZ.
Okay. Thanks.
I have a question on line 105. There's a simpler example. So vector 2 is like on line 105 to go down. So like on now 113, isn't the, yes, like this line,
Yeah.
aren't you testing vector 2 here? Is this test really necessary? Isn't vector 2 supposed to do this kind of test?
Yes, but this is a test suite for vector 2. I don't get
I
it.
You
saw the
implemented vector 2 yourself.
Sorry?
You implemented that yourself, vector 2.
Yes.
Ah.
Oh, yeah. Sorry, I forgot.
Are you showing the test? suite
Yeah,
for vector 2?
I'm because so I have three things. I have. I can do this.
I thought it's a library
Yeah.
you're using.
So yeah, I have so main dot Elm. This is my program, and then I extracted collisions and vectors because I could use them in other games. So there are other vector libraries, but I didn't use any external ones. And this is so. Yeah, it might be better to show you the code. So a vector is just a record that has two fields. You could define in many different ways, but like this, you can do stuff like dot x, and you access the field. So that's good. So yeah, I mean it's just basic math. And yes, it's kind of silly to test this. Yeah, I mean you should always have tests, but it's not the most interesting test. But I wanted to try something where property testing works and is kind of easy. Like here, I'm testing math properties. If you have your own code, the generation of the random input values for the tests gets a bit more tricky, I think. At least I haven't done it
for
yet.
the application itself.
Sorry?
So you have tests for the application
No,
itself?
not for the application itself. I might add some, but I was trying to like build piece by piece and understand how the testing works and so on. I forgot where I was. Yes. So if I run the tests. Okay. Hold on. Do you know what I'm missing? Yeah, basically what I wanted to show is that this will fail because when you
Using as parentheses.
Yes.
Close the line.
this one. I need a white space, but you got saying
White space.
one above as well. Yeah. Oh, yeah. Thanks. Oh, that's fast.
You need to add the test to the test suite.
Sorry?
You need to add the test to the test suite.
Yep, that's a good. Yeah, so this is just a list of tests, and usually you write them all in line, but it's like suddenly you have a big file where you don't see like different sections. So, but yeah, that's a single test fail. Cool. So it says, yeah, right here. It says that it found an example where this claim doesn't hold, and it did generate some floats with a lot of like position paths into comma. Yeah.
Don't you have flaky tests with that somehow? I mean,
What do you mean?
usually this is not repeatable, right? Next time you
It
run
is
it, you have
repeatable.
okay.
Like if I rate it, so I can just. Those are the same, right?
Yeah.
Seems so. Yes.
Yeah. So it does have a strategy to shrink the examples to something that's repeatable.
Okay.
Yeah, probability-based testing. It's a whole other subject, and you can apply it in other places as well. But I found that Elm was a particularly good place because it's a purely functional language, and for like vector math, yeah, it kind of makes sense because. And I wanted to do more complicated examples. I'll see later. Because all the tutorials are about, like property testing. You have a list. When you reverse the list and you reverse it again, you get the same list as the beginning. And like, yay! But show me like business logic. But yeah, so far I've tried I copped out and did the really simple one.
Do you use some kind of element test runner, or is it just a custom?
Oh yeah, so the way it's done is here I defined another. So Elm has a thing to describe your project. It's like there's an index.json. No, what is it in package.json? Yeah. So Elm has something similar. But I didn't even write this. It got generated by the Elm package command, which installed the dependencies. And this was for this is for the project. And I wrote one for the tests. And I just point to the parent directory where the code is defined, so it will know how to resolve both like test dependencies and production dependencies, and I just define those two. Like Elm check is the property-based checking, and Elm test is the unit testing one. And then I wrote a script that basically installs the testing dependencies, and then it compiles the test file to JavaScript, and then runs the test with Node.
Yes. Isn't there an Elm test CLI which kind of does the same thing for you?
No, I'm not sure. There used to be, I think it used to be more complicated to make your tests run, and this is why you needed a test CLI, because printing to the console is a side effect. Like there need to be some extra stuff. But now you can just use Node.
Can you run those in the browser as well? Or does it not work with the property testing? I think I've done it with unit tests before. Doesn't matter.
probably be done. I don't know.
Yeah.
So yeah, this would be something you call from your what you call it, the CI server. I can answer all kinds of questions about Elm, but I think it's better if we wrote some code. It's easier to learn that way.
Okay. Thank you very much. I think it was really nice to see an example. But let's be active. Just for the organization stuff.
Even said it actually works.
It's new. So that might be the reason.
I don't know if someone wants really to present his project. I think now it's the time, but maybe it's better to organize the groups and to go and code. It's now, almost 8. I just want the next meetup will be in 2-3 weeks. I don't know where. If someone knows the host, or maybe we can have this place again. I don't know. Otherwise, it will be in the Equal maybe. And I'm organizing, or I start to organize a mentor program for young hackers. So if someone is interested in teaching, come to me afterwards. It's mainly in Elm, but it's generally stuff about web development. And yeah, here we have some projects. I think I will just write the Elm Zürich website. I'm really interested in using the navigation, the new package. So if someone wants to join me to try this out, I want to make like a micro app for the navigation. So I'm using it now, but it's too complicated if you have the navigation in the main app. In the main model and update and something. I just want to move it in the micro application you can use over and over again. And yeah, for the, you two are new to Elm, I guess. If you want, I can also show the architecture and the basic stuff if you are interested. And we have so for the beginners, if you're interested, we have the QR code.
Yeah, this is.
I think it's not for today. Yeah?
My project, but no. Well, we have another idea we discussed this week because we had our JavaScript build here at Simplificator, and we did a simple React app there, and we might just try to migrate that to Elm or just build the same thing in Elm and see how it compares.
So if someone is interested, we'll just pick your people and you can start right away.
I will be.
Okay.
Me too.
This one. So we have also the website, the navigation stuff. Just come to me. We have the migrate the simple game. I think it's Simon and Marco already.
It's me. I'm Simon. We've written Super Hexagon in Elm, but it's 0.16 with using signals, and I tried to change it maybe a bit to use the new function.
Okay, if someone is interested, join Simon. I'll do interested in this.
I got challenged today that a couple of colleagues from me, they have an internationalization library and they depend on kind of localization files, which is kind of free JSON structure. And they told me today that it was really, really difficult to parse that JSON structure. So I haven't actually used the Decode library, so yeah, it's kind of related to this. I'd like to see if that became
Right. Yeah, definitely. Okay. Something else? More projects? Does everyone know where to go? What to program, what to join? Yeah? Great. So let's start.
Yeah, so you have 2 meeting rooms. You can also go into the kitchen, or you can go to the couches there, to this table, the table in the walkway, or here even. Go wherever you want. Yeah, I think it's a nice space. Yeah. And there's a Wi-Fi password, in case you're interested. HURZ, HURZ.
Okay.
Yeah.